Okay, so today we will do the discussion for the M1 paper of January 2022. Let's start with the first question. A particle of weight 5 Newton is attached to one end of a light inextensible string. Okay. The other end of the string is attached to a fixed point O. The particle P is held in equilibrium by a force of magnitude F newtons. The direction of this force is perpendicular to the string and OP makes an angle of 60 with the vertical as shown in figure 1. So part A, find the value of F. So when you come to this kind of a question, when you come to this sort of questions, is actually what we saw. They say here the word the particle is held in equilibrium, right? So when it comes to this equilibrium sort of sums, there are only 3 things that you need to do. What are the 3 things? You can take vertical equilibrium, the upward forces equal downward forces, or you can take the horizontal equilibrium. And then the last thing that we have is we can consider, what is it? We can take moments. You need to consider moment. Moments about any point will be 0. So those are 3 things you need to consider. So to find the value of F, okay, before we find the value of F, first thing is you have to mark all your forces. Shall we mark all the forces? So what are the forces? A particle P of weight 5 Newton. So we'll mark all the forces concerning our particle. Okay, our particle is the main person here. So we'll mark all the forces acting on the particle. First one is the weight 5 Newtons. What else? What are the other forces acting on the particle? Yeah, so it is attached to a light inextensible string, which means you have tension. So here we have a tension. The tension is a pulling force. So there is equal opposite tension to the wall, so we don't need that. Okay, then the next thing is, okay, so all our forces are done, right? Yeah, that's it. These are all the forces we have that are acting on our particle. So now what we'll do is we will resolve. So let me draw this line here. And now to resolve our forces, obviously I need an angle here. Do you see the angle that I'm using? So you can see here this angle is how much? It is 60 degree because of alternate angles. Okay, 60 degree, and then because this is 30 here, this is a 90. Since we have a perpendicular here with the 60, this guy should become a 30. Are you all okay with that? Is that okay? Okay. So to find the value of F. Find the value of F. Okay, so they want to find the value of F in part A and find the value of the tension in part B. So once again, there's a really important thing. You cannot use now by any chance you can't use the help of part B to find the answer of part A. Okay, is that clear? That means you cannot find tension first and use the tension answer to find friction. Okay, so then you have to find some kind of way here to find the not friction, to find the force F. Okay, you have to find force F. So what's the technique we should use? Should I use vertical equilibrium, horizontal equilibrium? What should I do? How do we work here? Okay, so now thing is we can definitely do vertical forces. We can take vertical equilibrium and horizontal equilibrium. However, that gives me an equation in both P and F, right? Yeah. So anyway, if you get 2 equations with P and F, you have to make sure. Now you will actually get a pair of simultaneous equations here. If you do vertical equilibrium and horizontal equilibrium, are you with me? You will get a pair of simultaneous equation. And however, if you get that, you need to make sure you find the value of F first, because it's mandatory you find tension second here because it's in part B. So shall I teach you a better way in this situation? In this situation, what we'll do here is, now you can see we already have a perpendicular here, right? Okay, what I'll do is, instead of now we normally feel like resolving the F here, going for, now normally you would go this and write this is F cos 30, right, towards the angle, and you would write this as F sin 30. That's what you would do, right? Instead of going in that path, since I'm trying to get the equation here only with T and F, what I'll do here is I'll resolve this in a little bit of a different way. What if I resolve my 5 newtons? Just have a look at what I'm doing. Do you agree that if I mark this angle here as 30 degrees, it's vertically opposite? This is 30 degree, right? Can you see? Vertically opposite angle, this 30 degree comes over here. And if I take this the other way, this is the other one, the other component. So if I write like this, do you agree with this is 5 cos 30? and this one will be 5 sine 30. This is okay. 5 cos 30 and 5 sin 30. End of the day, all the forces, what I'm doing here is I'm creating a system of forces that are not, I'm going to take the equilibrium perpendicular to this, perpendicular to the OP line and along the OP line instead of going in the traditional equilibrium. Like direct vertical and horizontal, I'm going to go in the a little bit of a different way where I will be taking perpendicular to OP line as my y-axis and along the OP line as my x-axis. When I do like this, now do you agree that all these forces are now perpendicular to each other? So then perpendicular, but what we can do is along the plane forces are equal to each other separately, and perpendicular to the OP plane, these two forces are equal to each other separately. And then we can get the answer for F and T. We can get it. We can get it separately without depending on each other. So for example, here, what happens? F becomes equal to what? In part A. F is directly equal to what? Look, F is perpendicular. So F is directly equal to whom? 5 cos 30. This is the direct answer. F is equal to 5 cos 30. Okay, so then what's the answer? 5 times cos 30 is root 3 over 2, right? So basically, F is 5 root 3 over 2. Part B, what's the tension in the string? So I need to work really hard here for tension in the string. I have to consider along the OP line. If I consider along the OP line, I get tension equals to what? 5 sine 30. I get 5 sine 30, which is in other words 5 into half, which is 5 over 2 newtons. So I get my answer for A and B. Now in here I find the answer for F without depending on T. And here I'm finding my answer for T separately. Okay, now it's actually okay if you use vertical and the normal vertical and horizontal equilibrium. But the thing is this, when they have part A and part B, it's very strict that you do not use the T value to find the F value in any way. Okay, you have to find F value and then using F you can find T. That is okay. But you cannot use part B to do part A. You can't do part B first and use that answer for part A. Okay. Okay, so once again, just to give you an idea, here instead of using the traditional x-axis and the traditional y-axis in this manner, I changed my x and y-axis to what? Perpendicular to the plane and along the plane, like this. Okay, so this is what I use for my y and x-axis. Okay, so vertical, horizontal, I slightly change it. End of the day, all of these are perpendicular, and then any force that is not in according to these axes, I resolve it. For example, this 5 Newton was not onto these two axes, so I resolve the 5 Newton. And then I'm using along this line, the y-axis, the perpendicular line. I'm taking the equilibrium, and along the plane, along the OP line, I take the equilibrium. Okay, so that's the easiest way to get this sum done. Is that clear? Okay, let's move to the next one. Okay, question number 2. A particle P has mass km and a particle Q has mass m. The particles are moving towards each other in opposite directions along the same straight line when they collide directly. Let's draw it. So there are two particles. Particle P has mass km and particle Q has mass m. They are moving towards each other in opposite directions. Okay, so opposite directions, they move towards each other. Immediately before the collision, P has speed 3u and Q has speed u. As a result of the collision, the direction of motion of each particle is reversed. So they are very clearly telling you the directions. Okay, very clearly they are telling you after the collision, as a result of the collision, the direction of motion of each particle is reversed. So I have the habit of writing the speeds after the collision. I write it underneath the object. So then this P is reversed, which means P will go behind and Q will go the other way. Whichever the direction they came, they get reversed. So they say here, the direction of motion of each particle is reversed and the speed of each particle is halved. Okay, so which means what? The speed 3u becomes, each particle gets half of its speed now. So which means 3u becomes how much? 3 over 2, yeah, 1.5u, and speed u becomes 1u becomes u over 2 or 0.5u. Okay, 3 over 2 and u over 2. So basically, I know the directions that they are going and I even know the magnitudes. Do you see it? So they are asking you, first one, find the value of k. Okay, so what are the principles that we use for questions like this? So for collisions, we use what? The law of conservation of linear momentum. The conservation of momentum. Conservation of momentum. By using the conservation of momentum principle. So what do we know? Initial momentum is equal to the final momentum. So select a positive direction that we consider for the entire sum. I'll choose the going to the right as positive. So what do we get? Initial speeds are marked at the top, final speeds are marked at the bottom. So according to conservation of momentum principle, initial momentum must be equal to the final momentum. So what is the initial momentum we have? Mass into velocity. Multiply the mass with the respective velocity. So Km into 3u, and that is forward, right? And the next one plus m into u, that is backwards. Can you see? So this is initial momentum equals to final momentum. Who is final momentum? Km into 3 over 2u, that is backwards, plus m into u over 2, and that is forward. Do you see? Initial speed in this side, final on the other side. Now let's fix all the directions. So how do we fix all the directions? This becomes 3 kmu. Is that okay? And this plus mark becomes what? In this case, when I fix the when I turn this to the other side, this becomes minus mu. Are you with me? I changed the direction. That's why it's becoming negative. Positive becomes negative because I changed the direction. Equals on the other one. Here also I'm going to change the direction, right? So this becomes what? Minus 3 over 2 kmu. And this one, I don't need to change the direction, right? So this is mu over 2. This is okay. So then what's the next easiest thing you can do here? You can cancel off. You can cancel out m. Everyone has the letter m. So you can remove m from the entire sum. Everyone has letter m. And everyone also has letter what? U. So we can even remove the u. So everyone removing u from all the terms. So all the terms have mu in common. So remove it. So then I end up getting here 3k minus, when mu is cancelled out, you just get 1 here, right? This is 1 mu equal minus 3 over 2k plus this is the 2 is in the denominator, so which means this is a half. Do you agree with me? Take all the k terms to one side. 3k plus 3 over 2k equals minus 1 goes to the other side, plus 1, and this plus half. How much is it? 3 plus 3 over 2 is 9 over 2k. Am I correct? 1 plus half is 3 over 2. And then the 2 and 2 will cancel, making k the subject. We get what? 2 into 3 over 9 into 2, right? This 2 goes up here, this 9 comes down here. And you can cancel 2 to 3 over 9, which means k is equal to how much? 1 over 3. K equals to 1 over 3. Is that okay? Next part. Part B, find in terms of m and u the magnitude of the impulse exerted on q in the collision. So they want you to find the magnitude of the impulse exerted on q. So basically, how do we draw the impulse when the two particles collide? Each of them get an equal opposite impulse, right? Each of them get an equal opposite impulse. P feels the impulse which way? P, when P and Q collide, P will feel the impulse in this direction, right? The way I driven, Q will get the equal opposite impulse to the other direction. So both of these impulses are equal and opposite. So they ask you to find the impulse exerted on Q. Basically, you could find it from anyone. Okay, so anyway, I think it's easier if we go with P. It's easier if we go with Q. The reason because the mass is also in terms of m, and we know both the velocities. So what's the equation to find the impulse? I equals to mv minus mu. I equals mv minus mu. So then choose a positive direction again. So my impulse is positive to this direction, right? To the right direction. So I'll use the right direction as positive. So I equals, what's the mass? Mass is m. Final velocity is u over 2 minus, and that is to the u over 2 is to the positive direction, right? Yes. And minus m into initial is how much for this person? For q, I'm using I equal mv minus mu on q, okay? So for q, initial speed is u. And even though I'm using u here, this u is to the backward direction. Do you see it? So I need to use I equal MU minus MU to the right direction because the impulse on Q is acting to the right. So this direction we need to fix it. So how do we fix it? How do we fix it? We need to turn the direction to the other side, which means the negative becomes positive. And then we get MU over 2, and now both of these directions are to the right. Okay, I change the direction here, the negative becomes positive. So now add them. Sorry, there's no over 2 here, right? Just MU. MU over 2 plus MU. How much is it? Half MU plus 1 MU. Basically, it's 1 plus half. How much is it? 1 plus half is 3 over 2 and MU. Okay, 3 over 2 MU. So this is the magnitude of the impulse exerted on Q. Basically, this is the same impulse you would even have on whom? It's the exact same impulse that you would even have on P. Okay. So now, question number 3. A beam ADCB. Okay, the beam ADCB has length 5 meters. The beam lies on a horizontal step with the end A on the step. Okay. The beam lies on a horizontal step with the end A on the step and end B projecting over the edge of the step. Do you see it? So this part of the beam is it's over the step. Okay, this AD is lying on top of the step. Then the edge of the step is at the point D where DB equals 1.3 meters. Okay, all of those information are marked in the diagram, right? As shown in figure 2. When a small boy of mass 30 kilogram stands on the beam at C where CB equals 0.5, the beam is on the point of tilting. And they say the boy is modeled as a particle and the beam is modeled as a uniform rod. Okay, so these things you need to first of all, there are several things you need to understand here. Find the mass of the beam. Okay, the first thing is a uniform rod means what? A uniform rod means the weight of the rod acts at the center. So then what's the weight of this rod? Have they told us? Oh yeah, the mass of the beam is what we need to find. Okay, so then weight will be, if the, let's say the mass is M, so weight will be mg. Are you okay with that? So let's put the weight as mg and weight acts exactly in the middle. Okay, so that means what? It's going to be 2.5 meter, 2.5 meter to each side. Is that okay with y'all? So it's 2.5 meters in here and 2.5 meters to the other side. Okay, and then the next thing, can I also know this distance? 1.2. This is G, right? Let's say this is G, the point where the center of mass of the weight exactly is G. Can I know the GD distance? I mean, you know, G to B distance also should be 2.5, right? Because G is the center of the rod. So if this is a GB is 2.5, how much is GD? From 2.5, you could subtract the 1.3. So 2.5 minus 1.3 is 1.2. Can everyone understand how I got the 1.2? From 2.5 from the GB 1.2 from the GB 2.5 length, I subtract the 1.3. Okay, now okay, I have the mass. I have marked the weight of the beam now. The next thing, the next most important thing you need to understand is they say when the boy is standing, when a boy of mass 30 kilograms. So let's mark the boy. So here you have a person who is of weight 30 kilograms, which means the weight is 30 G, right? So here when you have a weight of 30 G, what's happening? When you stand at the point C, the beam is on the point of tilting. Now tell me, now you can use your imagination. You have a step here and this is like a plank that's and part of the plank is outside of the step. So when this boy is standing here and if it's on the point of tilting, where do you think it will tilt around? Where do you think this plank will, this rod will, the beam, where do you think the beam will tilt around? Which point? Is it tilting around A or G or D or B? Which one? Around where? Think properly. Think properly. Now you are on this step. Now this is the step here. Yes. So I'm asking you where is the pivot point? So this is the step. So do you see that when this person stands over here, the tilting has to happen around where? It has to happen around D. Right? You can't. I mean, the tilting has to happen because of this boy's weight. The plank is trying. I mean, you feel like you're trying to go down, and that means this other part of the plank tries to go up. Isn't it tilting? Anyway, you because of the step here, this part of the plank cannot move down. The only direction it can move is to move up. So then when this part of the plank goes up, the other part of the plank goes down, meaning it's tilting around the point D. Okay, so that's the thing you need to realize here. Okay, so when the boy is standing at the point, the beam is on the point of tilting, so you need to realize, okay, if it's tilting, it has to tilt around D. So this is the main point. So whenever they say that you're tilting, remember we take moments, and we need to take moments around the point that the actual tilting is going to happen. So take moments around that point D where the tilting is happening. Okay, so this is the place where the tilting happens. Then that's the place you must consider moments, not anywhere else. Don't take moments around any other place. When the word tilting is there, okay? Unless if it's a normal equilibrium question, you can take moments around any point. But when it's a tilting question, take moments around the tilting point. So then let's take moments around the tilting point and find the let's find the mass of the beam. So basically, what about the normal reaction? You don't need to consider any normal reaction here, right? You realize why? Because when it's at the point of tilting, this part is like slightly lifts off. So then you can realize that there will be no normal reaction. The entire weight of the rod and the buoy, the beam and the buoy, all the weight will concentrate upon there. The entire weight will concentrate at the point D. So you will definitely have a reaction at D. But since you are taking moments around D, do we need to consider that normal reaction or any force that acts here? No. Okay, so we'll take moments around D. So taking moments around D, let me take clockwise as positive. So what do we get here? From point D, you can see to the point D, the 30G makes a clockwise moment or anti-clockwise moment. From the point D, 30G is moving down. The 30G is pulling this down, right? So this is going this way, which means around D, it's going to give you a clockwise moment. Do you agree with me? So then moments force into distance. So it's a clockwise moment, so positive. 30G multiplied by what's the perpendicular distance between D and C? I think you'll have to find it, right? Can I know the perpendicular distance between D and C? What is the perpendicular distance between DC? How do you get it? From 1.3, you subtract 0.5. So from 1.3, when you subtract 0.5, how much is it? 0.8. Can everyone understand? 0.8 came by subtracting 1.3 with 0.5, we get the middle distance, DC. So then 30G is the force, and perpendicular distance to point D is 0.8. 30G into 0.8 gives a clockwise moment. And then the other guy is this mg. So around the point D, mg is going to give you a clockwise moment or anti-clockwise moment. When you pull mg around D, this mg pulls down, and you need to see that it pulls it in which way? This mg around point D, it will pull this in the anti-clockwise direction. Do you see it? So what is the moment here? So you get here minus, because it's anti-clockwise, force is mg into perpendicular distance is 1.2 meters. Okay, so don't put another m here and confuse it with the m that you have for mass. This is 1.2 meters, not mass as in m. Okay, I should have used a different letter. So anyway, just be careful here. Okay, 1.2. I'm not going to use 1.2 meter here. 0.8 meter. I mean, just be careful. So then this is when they say it's on the point of tilting. It's on the point of tilting means the object is what? Still in equilibrium. Okay, it's still in equilibrium. So you make your sum of moments equal to 0. Okay. Then get the value of m. Find the value of m. Solve this equation. So how much is m? 30G into 0.8 equals mg into 1.2, making m the subject. So 30G into 0.8 equal G into 1.2 comes down. How much is m? So you can type in the cal, it becomes 20 kilograms, right? So your mass is 20 kilograms. Okay, we'll move to the next part. A block of mass x kilogram is now placed on the beam at A. Okay, so as a block of mass capital X kilogram, it's placed on the beam at this point A. The block is modeled as a particle. Find the smallest value of x that will enable the boy to stand on the beam at B without the beam tilting. Okay, so what do they want? Now we need to find out like change diagram again. So now where is the boy standing? In point B. First of all, in part B, they say they are having a block of mass x kilogram. So at point A, you have a block of mass x kilogram. So mass x kilogram is weight is xg, right? The weight is xg. So there's a block of mass x kilograms. And then the boy is now where? At the point B. The boy is at the point B. Do you agree with me? So boy has a mass of 30 kilograms, which means it's 30g here now. It's 30g at this point. Are you with me? So now, what do they want you to find? They are asking you what is the smallest value of x that you can have such that the boy can go to the corner. You know, he's at the point B and he can go to the point B without the beam tilting. Okay, so you do realize once again that even when you go to the point B, where if there is a tilt, where will this tilt occur? The tilt is definitely occurring at D because this is the edge of the stair. The tilt is occurring at the edge of the stair. So when you have something heavy here, the feeling is that this part will go down and this part will lift up. That's the feeling that we get, right? So basically, when you're at the edge of the stair, the tilting part will happen. This goes down, this goes up, and the tilting will happen around D. Okay, so now what they do is now they place a mass here. So in order to what? So with the support of the mass here, you realize that it can stop, it can help to prevent the tilt, right? So they are asking you now, the boy is at this corner and they are, and they have placed this weight, they have placed the support weight at this end. And they are asking you how much is this x so that this boy can stand here safely. So once again, what we'll do here is to find the smallest value of x. What you do here is, let's again take the, for the smallest x value, what do you think is going to happen? Now, you know, if this weight is really big, if you have a really large weight, you can see that we can go to this corner without any fear, right? For a really large weight, the more heavier this is, we can go to this corner with confidence, right? But now they're asking you not the, they're asking you for the smallest value of x. Like what's the minimum weight we can have here so that the boy can safely reach here. So when you reach the, when you have the smallest possible weight here, what do you think will happen when the boy reaches B? If this is the smallest weight that you can put, smallest means the smallest safe weight. Okay, not the smallest safe weight that I can use here so that I can go here. So what will happen? At the smallest safe weight, when you come to this point, what do you feel? You can again feel that the rod will what? The rod is about to tilt. Okay, because if it's about tilt, I mean, if this weight is really large, then you can come here and this will not even tilt. Like you can stand here confidently. But when this weight is a little bit like, when you have, there's a margin. Basically, what they're saying is there's a margin of the weight here. What is that margin value? So that you come here and that you can just barely reach here. You barely reach the end. Do you get what I'm saying? So when you barely reach this point B, what happens is this weight, even though you put it here, now you know basically when you walk on this without this support at it, without this weight X, you realize in part A when we reach point C itself, the tilting began, right? Without this weight. Now when the boy was in part A, the boy was at point C and it was about to tilt. Right, so then you know definitely without the support, can you go to the other side? No, definitely this will fall. So then because of this weight, now they are putting the weight so that the boy can travel to this corner. But then they want the least possible value of x. So to get the least possible value of x, what again needs to happen here is when you reach point B, then again the object must be, this plank must be on the point or about to tilt. Okay, so that gives the least possible value of x. That clear? Which means what about tilt means again the entire weight of the whole system comes here on D. The entire weight of the entire system comes on D and the system is tilting around point D. Do you realize what I'm saying? So again, what do we do for part B? You again take moments around whom? You again take moments around the point D. Shall we take moments around point D? Now there are how many forces? So now there are there's 30G, there's mg and there's xg. There are three forces to consider moments. Let's take moments. So 30G is giving a clockwise moment or anti-clockwise moment around D. 30G gives you a clockwise moment. So take the clockwise moment. What is it? 30G into 1.3. Is that okay? 30G into 1.3 is a clockwise moment. Okay, then the next one. mg gives you a clockwise or anti-clockwise moment around the point D. So you can see mg gives you a anti-clockwise moment around D, right? So this is pulling down. So it gives an anti-clockwise moment, which means minus mg into how much? The perpendicular distance from G to D is 1.2. Are you with me? And the next one, around point D, what's the next person I have to consider moments with? I have to consider X. So X is pulling down, which means it gives a clockwise and anti-clockwise. X is pulling around D, this is downwards, so it gives anti-clockwise, which means it's negative xg into what's the distance from A to D? You'll have read it, right? The distance from A to D is 2.5 plus the 1.2. Are you with me? It's 2.5 plus 1.2, the distance from A to D. The distance from A to D. Okay, so and then all of this, because it's about to tilt at point B, this must all be equal to 0. This must all be equal to 0. Now what do? Make X the subject. Let's make X the subject. Okay, then let's make X a subject. So I get here 30G into 1.3. M value was found in the previous part. It's 20G into 1.2. Minus xg goes to the other side as plus. Positive xg into 2.5 plus 1.2 is 3.7. Am I correct? G is common to everyone. We can remove. G is common to everyone. So at 30 into 1.3, we have to subtract 20 into 1.2. And the whole thing divided by 3.7 should give me the x value. What is the x value? Type it in the cal. What did we get? 20 into 1.2 over 3.7. So I end up getting here 150 over 37. Or I'll write here first. I'll write the exact value first. 150 over 37, which gives me how much? Which gives me 4.05 when I write it to 3SF, right? 4.05. So this is in X is again kilograms. Okay. 4.05 the weight. This is clear? Okay, then the next part. State how you have used the modeling assumption that the block is a particle in your calculation. So again, the modeling assumptions are given in your M1 book in chapter 1. They have given a table for the model and the modeling assumption. So this is there in your book. So it says when your particle, for a particle, the modeling assumption is the mass acts at a single point. Okay, or the mass is concentrated at a point. Okay, so basically write down the modeling assumption. Mass is concentrated at a point. Okay, or mass is acting at a point, something like that. You can refer your textbook and it's there. Okay. Then you're done with this question. Question number 4. At time t equals 0, a small ball is projected vertically upwards from a point A, which is 24.5 meters above the ground. You see this? The point A is what? 24.5 meters above the ground. The ball first comes to instantaneous rest at the point B. So first have a visual idea of what's going on. This is the ground. So point A is above the ground. Is 24.5 meters above the ground. And then what do? We project the ball from point A, right? At time 0, the ball is projected vertically upwards from point A, which is 24.5 meters above the ground. The ball first comes to instantaneous rest at point B. Where do you have point B? So if you are throwing this up, where does the ball come to instantaneous rest at for the first time? You're throwing the ball up, so it goes up. Where does it come to instantaneous rest? When it goes to its maximum height. At the maximum height, it comes to instantaneous rest. So at the maximum height, you come to instantaneous rest, and this is your point B. Okay. So then, and they say the ball comes instantaneous at the point B, where AB. So AB distance is 19.6. So this AB distance is 19.6 meters. Okay. And first hits the ground at time t equal capital T seconds. So when it first hits the ground, this ball goes up to point B and it falls down. Are you with me? It falls down and falls down. When it hits the ground again, it will come down and hit the ground again. When it hits the ground, the time is capital T. So at A, your time is 0. Do you see these important things? At A, time is 0. You throw the ball up, it goes to point B, and when it comes down, and when it hits the ground, the time is capital T. The ball is modeled as a particle moving freely under gravity. In the part A, they are asking you to find the value of T. Okay, how do we find the value of T? So it's 6 marks. You can use any motion equation. Right, so what's the easiest equation to use here? S equals ut plus half a square is the easiest, right? Directly we use it from point A until you hit the ground. So let's say we hit the ground at this A, B, and let's say the ground is C. So I'm going to use S equal ut plus half a square directly from A to C. Directly from A to C. And which direction do you consider as positive? It's entirely up to you which direction. Okay, so if you consider upwards as positive, then from A to C, okay, it's up to you which direction you consider positive. Okay, so then from A to C, what's the displacement from A to C? Starting from A to point C, what's the shortest distance from A to C? It's clearly seen here, right? From A to C, what's the shortest distance? From point A, it goes up and comes down. End of the day, what's the displacement from A to C? It's 24.5, but is it just 24.5? I have used this equation upwards, A to C, but my A to C displacement is not upwards. From A to C, my displacement is downwards. Therefore, we need to have a negative sign here. Okay, this entirely depends on the direction that you choose at the very beginning. Because you could choose to give this equation as downward positive. In that case, A to C displacement downward is positive. Okay, so anyway, choose one direction and go with it. Okay, so we are going to choose the positive as up. So from A to C, we don't have upward displacement, we have a downward displacement, so negative. What about the starting speed U? U is not given, right? Okay, U is not given, it's okay. Yeah, in this case, we have two unknowns. We do not know U and we do not know T. Okay, so why don't we know? Instead of using from A to C, let's try another approach. Okay, this approach doesn't work because we do not know U. Let's try another one. Okay, so before we apply from A to C at the beginning, we need to find the value of our U. Shall we first find the U value? So how do I get my U value? We'll apply V square equal U square plus 2AS from where to where? From A to B. Because the reason from now, we know our motion starts at A. Just keep in mind, do not confuse, the motion starts at A. Okay? Okay, so then let's find the value of our V. Find the value of our U, right? Let's find the initial velocity by applying V square equal U square plus 2AS from A to B. So what's our final velocity? At point B, we reach the maximum height. V will be 0. I'll apply this upwards, by the way. Okay. And what about U? Starting speed is what I'm trying to find. U square plus 2 into what is the acceleration? The particle is traveling freely in air, right? So when the particle is traveling freely, what is your acceleration? Gravitational acceleration is 9.8. However, what 9.8 are we using? Minus 9.8 because our object travels, we use the equation upwards. And the displacement from A to B is? The displacement from A to B is 19.6. Are you guys okay with what I'm talking about? Make use per the subject. So this entire term, the negative sign comes forward. So it's a negative term. The entire negative term, I'll take the other side as a positive. 2 into 9.8 into 19.6 and then get the answer and square root it. How much is it? So 2 into 9.8 into 19.6 gives me u square. Okay. Then I square root my answer and I get 98 over 5, which is 19.6. Are you guys okay with it? So square rooting this gives me 19.6. So this is the initial, the starting speed. Okay, so now I can go to the equation that I was trying to use earlier. Okay, because I want to find the value of capital T. Basically, capital T means the time taken to go from A to B and then to C. It goes up and it comes down. But remember, it starts from point A, not from the ground. Okay, so going up to B and coming down again. So what is the equation? Let me use again. S equal ut plus half at square from A to C. And I'll use it as you suggested earlier. Let's use it upwards. So what do we get here? Displacement is from A to C. We don't have upward displacement. The displacement is downwards 24.5. So I will use negative 24.5. What about the u value? U is, we found the initial velocity at A is 19.6 meters per second upwards. And the T value is actually the capital T, right? The time taken to go from A to C is our capital T. The capital T plus half into the A acceleration due to gravity is 9.8, and this time it's a positive or negative 9.8. Is it positive or negative? Based on the direction that I'm using my equation, G should be, look at the direction, we are using upwards. Gravitational deceleration is acting downwards. Then this is against that. So this is negative 9.8 into time is capital T square. Is that okay? Okay, now solve the equation. This is a quadratic equation. Just type the coefficients in the calculator, get the answer. So we get 0. I get here 0. Half into minus 9.8 is minus 4.9 T square plus 19.60 plus 24.5. Okay, so if I arrange it here,
we get 5 and minus 1.
Okay, yeah, so then we'll apply to the equation T equal minus B plus or minus square root B square 4 into A into C. You could arrange this nicely. I mean, the equation you could multiply it with a remove the decimal by multiplying everyone by 10 and also rearrange. Okay, these are like there are many options you can use. I'm just going for the equation. You can just type these values in the calculator, just show a method. So we have some kind of method now for getting the T value. Okay, so it's there to be seen now. So what are the answers we get? Yeah, 5 and yeah, decrease to, let me just type 4.9 minus 19.6 and 24.5, and I get the answer, sorry, 4.9 minus 19.6 and minus 24.5, right? Yeah, so we get the answer T equal 5 and T equal minus 1. It should be minus, right? So T equals to 5 or T equal minus 1. So you know time cannot be negative. So the correct answer for T is T equals to 5. Okay, so that's the answer for part A. 6 marks. Let's move on to part B. Sketch a speed time graph for the motion of the ball from time T equals 0 to time T equal capital T. Okay, let's draw the graph. So there is a question asking like, can't we find the time separately? Yes, you can find the time separate. Now for part A, I found the value of T in a direct way, directly going from A to B, A to C, right? But you can actually break the time and find, meaning you can find the time taken to go from A to B by using V equal U plus AT. And again, you can find the time taken to come from B to C, okay, by using S equal UT. Okay, S equal UT plus half X square. So you can do that. That's perfectly fine. And you can add the 2 times from A to B, B to C, and you can directly get your answer as 5. So those methods are all correct. Okay, now we'll move on to part B. Sketch a speed time graph for the motion of the ball from T equals 0, T equal capital T. T equals 0 is the place where you start. T equal capital T is the place where you hit the ground. So tell me, how does the speed time graph work? So it's not a velocity time graph, right? It's a speed time graph. Do you notice the word here? Speed time graph. So it's a scalar quantity, right? So in the speed time graph, okay, so in the speed time graph, how does it work? So you start with the speed of how much? The starting speed is 19.6. Are you all with me? Starting speed is 19.6. And what happens? Is the speed increasing or decreasing? When you move up, you're going up. So when you're moving up along this, when you're moving, when the particle is projected upwards, the speed is decreasing, right? The speed decreases until you reach the maximum point, at which case the speed actually becomes 0. And you all know in a speed time graph, the gradient is the acceleration. So what is the acceleration here? We are traveling under the gravitational acceleration. So in this case, how do you draw the line? So it should be a straight line graph, right? No, it's not a curved graph because we have a constant acceleration. Isn't it a constant acceleration? Therefore, it's a straight line graph. Which way should I draw my line? Upwards or downwards from 19.6? From 19.6, we draw our graph downwards because we have a constant deceleration. So when you come to this point, what happens at this particular time? You reach speed 0. So at this point, where is the ball? The speed is 0 means the ball is at the point B. So you see the ball is at the point B. Okay, now what about the remaining part of the graph? Now in velocity, now after point B, the ball is now changing its direction completely, right? It's changing its direction and it's coming down. And when it's coming down, is the speed increasing or decreasing now? When it's coming down, starting from the speed 0, when you move down, you can see it's now coming under gravitational acceleration, which means the speed will increase. So which way do I continue this line? Do I continue drawing it down or should I turn and draw it up? We should turn and draw it up. Why? Because this is a speed time graph. In an event, if this was a velocity time graph, you would continue to draw this line down. Okay, but this is a speed time graph, so it's a scalar quantity, so we don't take it down, we turn it the other way. So, and when you take it the other way, what about the angles? Now you understand that we are again going under the same acceleration, right? Here, when you are going up, you have gravitational deceleration of 9.8. When you are coming down, you have the gravitational acceleration 9.8. So basically the slopes, the angles must look the same. And what about the line? Do I like stop midway or do I need to take this exactly to the length of 19.6 or do I need to go further? What do you think? Why do you say to go further? Because you can see here now, this motion is symmetric, right? Once the ball actually reaches this, now it goes up and it comes down here. When it comes down, again, when it reaches the same point as A, it will again get the speed 19.6. Do you see? Because it's symmetric, the motion, it comes here and when it's on its way down, when it passes the point A, it is again definitely at the speed of 19.6. Okay, and then what happens? It doesn't stop, it continues coming down, which means what? It continues increasing in speed. So therefore, your line should definitely be longer than the initial 19.6. Okay, because it reaches the speed beyond that. Okay, so you draw your line with the same angle. Try to keep the same angle. And make it longer. We simply make it longer. Okay, and the end of the line is at the point P. Okay. No further calculations are needed in order to draw the sketch, which means what? Normally, when we draw a sketch, we try to find the places where we cut the x-axis. So those things actually at the point B, what's the time value? However, they have very clearly said no further calculations are needed. Okay, so then this is it. This is enough. Okay. Question number 5. A particle of mass m rests in equilibrium on a fixed rough plane under the action of a force of magnitude x. The force acts up a upper line of greater slope of the plane as shown in figure 3. The plane is inclined at an angle alpha to the horizontal where tan alpha is 3/4. First things first, when they give you this tan alpha, first thing is you draw the required triangle and find what? We need to find the sine alpha and cos alpha. Okay, so get the sine alpha, cos alpha ratios, tan alpha, opposite over adjacent is tan alpha, right? So opposite over adjacent. So by using Pythagoras theorem, hypotenuse becomes 5. Are you all okay with that? So who is sine alpha? Sine alpha is opposite over hypotenuse, am I correct? And cos alpha is adjacent over hypotenuse, which is 4/5. Do you agree with my working? Then they say the next part they say is the coefficient of friction between the particle and the plane is mu. Okay. When x equal to p, so x is the force that is pushing this particle up the plane, right? So when x equal to p, the particle is on the point of sliding up the plane. When x equal p, the particle is on the point of sliding down the plane. Do you understand this question first of all? So x equal to p, now you can see x equal to p, and when you compare x equal to p to x equal p, 2p is the higher force, right? So when you give the 2p force, the object is on the verge of moving upwards. So when it's about to move up, what do we understand? When the particle is on the point of moving up. So when they say here on the point of, so on the point of means first thing is you need to realize when they say the word it's on the point of moving, this is what equilibrium? This is not the normal equilibrium. This is limiting equilibrium. In limiting equilibrium, there's one thing very special about the friction. Do you remember something about friction? Normally, when friction, I mean, we say friction has a limiting value, or there is a maximum value of friction that friction can reach. So when an object is about to move, or if it's moving, or if it's about to move, then you have reached the maximum friction, isn't it? So then when the particle is on the point of sliding up the plane, if your particle is on the point of sliding up the plane, what do you have to say about the friction? If you're trying to move up, friction will act opposing that, right? So you're trying to move up, so friction will act which way? Opposite. Friction will act opposite downwards. Do you agree with me? So this is also not just any friction. What friction? The friction maximum, the F max friction. Or I'll just use here the mu r friction. So I use like that. This is the mu r friction because mu r friction, maximum friction is called mu r, and maximum friction only occurring when your object is about to move, or if it's already moving. Okay, if object is in normal, just in equilibrium, if it's just in equilibrium, then we don't reach the maximum friction. Mark the other forces here. So I'm going to consider the first line. Okay, I'm going to consider this line first, and I'm going to mark my force diagram for this line first, and then I'll mark another one for the second diagram after that. Okay, let me take a copy of my diagram. So we'll use this for the part B later. Okay, let's work with this one now. So what are the forces we have? The object is x is equal to p. The particle is on the point of moving up the plane. Therefore, friction is acting. The maximum friction is acting down. Are you all okay with that? Maximum friction or the mu r friction. So what are the other forces acting here? What are the other forces we have? Mu r means definitely you understand you have the normal reaction, right? Normal reaction acting perpendicular to the plane. What else do we have? We have the weight. The weight is acting vertically down. Weight is mass is m. So weight is mg. Okay. Then let's write the equilibrium equation. So I will consider equilibrium along the plane and perpendicular to the plane. Yeah. So along the plane and perpendicular to the plane are my main directions. Along the plane and perpendicular to the plane. So then anyone who is not in these two directions, we need to resolve. So basically this mg, our weight needs to be resolved. The alpha comes over here, right? You all know about the geometry. You have learned this in M1. So this alpha comes over here by geometry. So what is the resolve? I want to resolve mg to the perpendicular to the plane and parallel to the plane directions. Okay. So let's resolve mg. What do we get? Towards the angle we get here mg cos alpha, and away from the angle we get what? Mg sin alpha. Are you all with me? So I get downwards mg sin alpha. Okay, I get mg sin alpha. Okay, now let's work. So I don't need to work with this weight mg now. I work with mg cos alpha, mg sin alpha. So now all my forces are in the parallel to the plane and perpendicular to the plane direction. So let's take the equilibrium. So what's the equilibrium we have here? Let's write down. First of all, your normal reaction perpendicular to the plane. Normal reaction is equal to mg cos alpha. Is that okay? And then that is the, when I consider perpendicular to the plane, now let's consider parallel to the plane. So what are the forces parallel to the plane? X equal 2p is acting upwards. Okay. So upwards we have 2p, balancing it out. Who do we have? 2p is equal to what? The mg sine alpha and the mu r. The mg sine alpha and the mu r balance out with the x equal 2p, right? X equal 2p is acting up. The mg sine alpha and mu r is acting down. So x equal 2p is balancing out with these two, and that's why it's in limiting equilibrium. Input the r value. 2p equal mg sine alpha plus mu r is mg cos alpha. Are you all okay with this? Shall we input the sine alpha and the cos alpha values? What was sine alpha? Sine alpha was 3 over 5 and cos alpha was 4 over 5. Am I correct? Mg sine alpha is 3 over 5. So shall I put 3 mg over 5 plus mu mg into cos alpha is 4 over 5. Shall I put 4 mu mg over 5? Can you understand what I did here? Cos alpha is replaced as 4 over 5. I just put it in front here. And sine alpha is 3 over 5. I just put it in front here. Okay. Then let's write the equation. Let's say this is my first equation. Let's write the equation for the next guy. So who is our next person? Let's consider the second point. So what's the second point? So what's the second point? They say when x is equal to p, the particle is on the point of sliding down the plane. So when they say the particle is on the point of sliding down the plane, now you can see the force is slightly less, right? The force is slightly less. I mean, you can see 2p is higher, p is considerably less. So now what's happening? It's on the point of sliding down the plane means what's the main thing you need to realize here? When the particle is on the point of sliding down the plane, then what is the force that needs to change here? The friction. Now previously the friction is always opposing the direction that you move. So if you are trying to move down, then friction now acts upwards. So now your mu r friction acts upwards. Normal reaction will stay the same. I mean, normal reaction stays the same, right? There's no reason for it to change. Mg also, you have the same weight. And your components are also the same, right? You have mg cos alpha and you have mg sin alpha. Is that okay? Okay, so now again do the same story. So R is equal to mg cos alpha, that doesn't change. Okay, R equals mg cos alpha is the same. So again, let's write another equation for the equilibrium along the plane. Let's write the equation. What do we have here now? X is now equal to P. So upwards along the plane, what do we have? P plus mu R. Do you see X equal P and X equal mu R are both acting up along the plane? Is equal to what? Mg is equal to mg sin alpha. Let's make P the subject. P equals to mg sin alpha minus mu times R is mg cos alpha. Is that okay? So P equals mg sin alpha is 4 over 5, right? Minus mu mg cos alpha is 3 over 5. Is that okay? Okay, so I have my two equations. Now it's a matter of solving these two equations simultaneously. There are many ways you could solve. You could like take the p value and equate that p inside here. Or you can divide your two equations. You can divide the first equation by the second and you can cut the p. I mean, there are many ways. Or else it's easier. I feel like it might be easier if we go with the sin alpha cos alpha form and divide. There are many ways. The simplification is entirely up to you. Okay. So it's entirely up to you. Just do it correctly. I'll go for the substitution method. Substitute. So what do we have here? 2 times the p value. Let's substitute our p value. What's the p value we found here? 4 over 5 mg minus 3 over 5 mu mg. Okay, I'm substituting to this equation. I'm taking this equation 2p, p is from here. equals 3 over 5 mg plus 4 mu mg over 5. Do you agree what I've done? Do you understand? I take this p value and substitute that in here. Do you see? So now what happens? Open the bracket. 2 into 4 over 5 is 8 over 5 mg. 2 into 3 is 6 over 5 mu mg equals 3 over 5 mg plus 4 mu over 5 mg. So everyone has mg in common. Do you see? So cut off the m and g values. Mg cancels. Mg will cancel out. Do you see? And actually, you can even see that everyone has 1 over 5 also is in common. Do you agree with me? Like basically, you multiply the whole equation with the 5. 5 will remove. So I get here 8 minus 6 mu equals 3 plus 4 mu. So then I'll take 3 to the other side. 8 minus 3 and I get here 4 mu plus 6 mu. 8 minus 3 is 5 equals to 10 mu. This is okay. Wait, let me check again. I think I have some error here. Let's check that. Okay, so there's a slight error here, right? The sine alpha should be 3 over 5. Cos alpha should be 4 over 5. Yeah. So let's fix that. Sine alpha is 3 over 5. Cos alpha is 4 over 5. Let's quickly fix it. The upper equation is correct, right? Sine alpha 3 over 5. Yeah. The first equation is correct. The second equation I need to arrange it. So this becomes 3 over 5 and this becomes 4 over 5. Is that okay? So when I multiply in here, let's fix it here. So I get here 2 times 3 is 6 mg, 2 times 4, 8. 6 over 5 mg, 8 over 5 8 over 5 mu mg. Is that okay? Okay, then I multiply the whole equation with 5. The mg can't cuts here, so I get 6 minus 8 mu. 3 plus 4 mu. Is that okay? So 6 minus 3, I get here 4 mu plus 8 mu. 6 minus 3 is 3. This is 4 mu plus 8 mu is 12 mu. So mu equals to 3 over 12, which gives me mu equals to 1 over 4. Basically, mu is equal to 0.25. So just be really careful. Okay, as you can see here. I hope you identified the error here. Okay, and I hope all of you understood the question. Okay, question number 6. In this question, I and J are horizontal unit vectors. Okay. A particle P of mass 2 kg moves under the action of two forces Pi plus Qj Newton and 2Qi plus Pj Newton, where P and Q are constant. Okay. So we have a particle moving under the action of two forces. Given that the acceleration of P is I minus J, find the value of P and the value of Q. Okay, so how do we find the value of P and Q? First of all, when there are two forces acting on a particle and if your forces are given in terms of I and J, what do? There's something called, we can find the resultant force. When your forces are given in terms of I and J, how do you find the resultant force? We can simply, when your forces are given in terms of I and J, the advantage is that you can find the resultant force simply by adding the two forces, adding the, if you, whatever the number of forces you have, as long as it's given in terms of I and J, just simply by adding your forces, you will immediately get the resultant force. Do you hear me? So it's a theory you learn in your M1 book. Okay, question number 6 part A. So let's get the resultant force. So resultant force is equal to, so we have Pi plus Qj and you have to add it with 2Qi plus Pj. So let's separate. I prefer to have my I and J separated. So what do I get here? P plus, so my I coefficients are Pi and 2Qi, which gives me P plus 2Q times I. And the other one I get Qj plus Pj, which gives me what? Q plus P times J. Are you okay? I separated the I terms together and I took the I out. And the J terms I took it together and I took the J out. So now they have given me an acceleration. They have given the mass. So what comes into your head? What should we use? We should use F equals MA. Use F equals, using F equal MA. So resultant force is P plus 2Q times I. Q plus P times J equal mass is 2 kilogram into acceleration is given as I minus J. So now they're asking you to find the value of P and Q. What do you think you should do here? It's simply a matter of what? Comparing coefficients. Just compare coefficients because the I coefficients on both sides must be equal to the I coefficients on both sides are equal to each other and the J coefficients on both sides must be equal to each other. So when I compare the coefficients of I get P plus 2Q is the I coefficient on the left side. On the right side, who is my I coefficient? So you need to make sure you multiply this inside with 2, right? So we get here 2I minus 2J, which means the I coefficient is how much? Is 2I here, which means I coefficient is simply 2. I mean the coefficient, just the value with I. Okay, so this is the first equation. Get the second equation, compare coefficients for J. When you compare coefficients for J, what do we get? For J, we have Q plus P here. Q plus P equal, what's inside? What is the J coefficient on the right side? What do we get here? What J? Is it just 2J? No, you get here minus 2J. So then J coefficient is negative 2. So now you have a pair of simultaneous equations. Solve it. So then we can just directly subtract. It's up to you all the way you solve it. Okay, P plus 2Q, I subtract with Q plus P. So I just need to get rid of one variable. Subtracting 2 with minus 2. Do you see what I did here? I took the first one, subtract with the second one, the first one, subtracting with the second one. Okay, are you clear with what I'm doing? P plus 2Q minus Q minus P. This is 2 minus is plus 2. Basically, the P will cancel off. 2Q minus Q is Q. 2 plus 2 is 4. Q is equal to 4. And then input the Q value into any of your two equations and get the P. So I'll use Q plus P equal minus 2. So Q is 4, right? 4 plus P is minus 2, which gives me P equal minus 2. The plus 4 goes as minus 4. Minus 2 minus 4 is minus 6. So these are my P and Q values, basically the answer for part A. Is that okay? Part B, find the size of the angle between the direction of the acceleration and the vector J. So what do they want? The angle between the direction of what? Acceleration and the vector J. So acceleration is given to you as I minus J, right? How do we get the direction? The best thing you do is just draw a diagram to represent the direction of acceleration. So how is your acceleration? How do we mark it on the diagram? There is the vector J. Vector J is the y-axis. Okay, vector I is x-axis. So in here, when they say I minus J, it's basically the coordinate is like 1I minus 1J. So basically 1 comma minus 1. Are you with me? So it's, yeah, it's 1. It's 1 comma minus 1, right? This is okay. So then what's the angle we get here? So then this is 1 comma minus 1. So this is my acceleration angle. Okay, so 1 comma minus 1, I think you really need to, you can definitely realize how much is this angle to the x-axis, for example. If it's going at 1 comma minus 1, both sides are equal to each other, right? So it's definitely how much? 45, right? You could do this in radians or in degrees. They have not specified. So it's 45 degrees here. You could use tan inverse and find tan inverse 1 over 1 is 45. Basically, it's an isosceles triangle here. You can see both sides are equal. Okay, but is this the angle that we need to find? No, we need to find the angle between what? The angle between the vector J. So vector J means the positive y-axis. Remember, it's not negative J. Positive J is the positive y. So from the positive y, get the angle. How much of an angle do we have from the positive y? So get this full angle. You could take it clockwise or anti-clockwise. So normally we go for the small angle because you can think of it. Why can't I take it to the other way? Yeah, you can take it to the other way as well. Okay. So normally we go prefer the smaller one. Is that okay? So how much is the angle? 90 plus 45 gives me how much? 135. This could be in degree or it could even be in radian since it's not specified in the question. Okay, so both are in degree or in radian, both answers are fine. Then let's move to part C. At time t equals 0, the velocity of p is 3i minus 4j. Okay, they have given you the velocity at a very specific point. I mean, at time 0 means what velocity? At time 0 means it's the initial velocity. So initial velocity is given as 3i minus 4j. At t equal capital T seconds, p is moving in the direction of the vector 11i minus 13j. Okay, find the value of t. Okay, how do we work with this? How do we work with this? They have given you the initial velocity. Starting velocity is 3i minus 4j. And we also know what? We also know the acceleration. Acceleration of this object is I minus j. And they say at the final velocity, for example, I mean at time t equals capital T, basically the final velocity is not given, but they have told you it's moving in this particular direction. They have told you that that your particle is moving in the direction 11i minus 13j. So how can we get the final velocity from this? So when they say you are moving parallel to the certain vector, we can get the velocity vector by simply doing what? How do we get the velocity vector? So basically when they say your velocity is moving in this direction, it means your final velocity is parallel to this direction, right? Well, let's do like this first. Shall we find the final velocity in terms of capital T? Let's find the final velocity in terms of capital T. Okay, we need to find velocity at time capital T. Okay, let's find this first. We'll use the equation what? V equals U plus AD. We're trying to find the, first I'll try to find my velocity, then I'll think about T. So velocity, final velocity equal initial velocity is 3i minus 4j. Acceleration is I minus j into time is capital T. Do you agree with me? Shall we separate I and j? I want you all to separate I terms and j terms. So 3i plus ti, isn't it? So you see, shall I do it in 2 steps? You could do this in 1 step at once. Okay, you could do this in 1 step at once. So I'm going to separate. This is 3 plus t times I. And here minus 4 minus t times j. Are you okay with this? I separated my I coefficients and j coefficient. Now, what do we know about the final velocity? They say the final velocity is in this particular direction, which means it's parallel to this direction. So, do you remember how we work with parallel vectors in M1? So, basically, they say your final velocity is parallel because it's in the direction. It's in the same direction, or it's parallel to 11i minus 13j. So, how do you get rid of the parallel sign? You make it equal to you can just put a constant by removing the parallel sign. So we can, this is my way of doing it. There are other ways of doing it also. You can divide and do. So basically all of them are saying the same thing. Final velocity is 3 plus ti minus 4 plus tj is parallel. To remove the parallels, and I'll put a equal and just put a constant. Just put a constant to one side. Do you see? The final velocity, I took it from the up over here. This V is replaced by this value here. The parallel I removed to put the equal mark, and when I remove the parallel with the equal mark, I should put a constant. Yeah, this is a theory we learn in vectors. Okay, so now what we do is we can compare our I and j coefficients. Again, compare your I and j coefficients. So when we compare coefficients now, so compare coefficients, what do we get? I coefficient, we get 3 plus t. On the other side, what's the I coefficient? What's the I coefficient on the other side? 11k. And then compare the j coefficient. What do we get? Minus 4 minus t is equal to what? What's the j coefficient here? K into minus 13 is minus 13k. Are you guys with me? So I think the best way to start this is, again, you can see a pair of simultaneous equation. Can you see? The best way to solve these two simultaneously is, I think we can divide. In that case, the k will cancel. Shall we divide? 3 plus t over minus 4 minus t equal 11k over minus 13k. Okay, you can come to this point directly from here. Like if you are seeing it, you can come from this point to this point directly. So I'm just showing you how it really came to that point. Okay. And now what? The K will cancel out. And now it's just a matter of multiplying and making what? T the subject. So minus 13 times 3 plus T, 11 times minus 4 minus T. Minus 13 into 3 is minus 39. Minus 13 into plus T is minus 13T. 11 into minus 4 is minus 44. 11 into minus T is plus 11T. Sorry, minus 11T. Is that okay? Minus 39 plus 44 equals minus 11T plus 13T. What do we get here? 44 minus 39 plus 44 is, we get here 5, right? 11T minus 11 plus 13 is 2T, which means T equals 5 divided by 2. 5 divided by 2, which is how much? 2.5. So 2.5 seconds. Yeah, so then it's moving when T equal 2.5, it's moving in this direction. So I hope this is clear with everyone. Question number 7. A particle P of mass 4m lies on the surface of a fixed rough inclined plane. Okay, so we have a fixed rough inclined plane here. I'm just marking this to remind myself that this is rough. Okay, on a fixed rough inclined plane, the plane is inclined to the horizontal at an angle alpha where tan alpha is 3 over 4. Once again, the same story. When tan alpha is given, you can immediately write sin alpha and cos alpha. Is that okay? So what is sin alpha and cos alpha? Tan alpha is 3 over 4, opposite over adjacent. By Pythagoras theorem, the hypotenuse becomes 5. So then we get here sin alpha equals 3 over 5 and cos alpha becomes 4 over 5. Is that okay? Then next they tell you the particle P is attached to one end of a light inextensible string. Okay, the string passes over a small smooth pulley that is fixed at the top of the plane. The other end of the string is attached to a particle Q of mass in which lies on a smooth horizontal plane, which means this Q is lying on a smooth plane. Do you see the difference? P lies on a rough plane, Q lies on a smooth plane. So make sure you get all those things properly marked. So that's why I marked this over here to identify that this is rough and this is smooth. The string lies along the horizontal plane and in the vertical plane that contains the pulley and a line of greater slope of the inclined plane. The system is released from rest with the string taut as shown in figure 4 and P moves down the plane. So they tell you very clearly what P is moving down the plane. So if P is moving down the plane, what happens to Q? P doesn't move along. I mean, P is obviously moving together with Q. They're connected particles. Therefore, if P is moving down the plane, what happens to Q? Q will be pulled. So Q will be pulled to the left side. Do you agree? Q is pulled to the left with the same acceleration, with the same magnitude of the acceleration. Okay. Then they are saying to you the coefficient of friction between P and the plane is 1 over 4. Okay, mu is given as 1 over 4. Mu is 1 over 4. For the motion before Q reaches the pulley, okay, so for the motion where before Q reaches the pulley, write down an equation of motion for Q. Just one mark. And okay, so let's write the equation of motion for Q. Before I write the equation of motion for Q, what do I need to do? I need to first mark all the forces. Shall we mark all the forces acting on P and Q? So what are the forces acting on Q? First thing we have is its own weight. So Q has its own weight mg. What else is there? Normal reaction. So we have the normal reaction acting on Q. RQ. I just marked RQ. What are the, and then what else? You have tension. Definitely we have tension. Tension acting on Q. Equal opposite tension acts on whom? The pulley. Don't forget that. So this tension belongs to Q. This tension belongs to the pulley. And then what happens? This tension, same tension moves to the other side, right? So you have the same tension acting up on P and you have the tension acting down on the pulley, equal opposite tensions. This is okay. What else? What are the other forces we have here? Can you all quickly tell me that I want the full force diagram to be complete? Weight of the particle P is 4 mg. And normal reaction of particle P is acting perpendicular to the plane. So mark normal reaction perpendicular to the surface. So this is normal reaction P. And then what about, since it's a rough plane and it's moving, we have friction. So what is the friction we have? We have the maximum friction here because the object is moving. Which way do we mark the friction? Which way do we mark the friction? The object is coming down means friction is acting opposing the motion. So friction acts up. So we have not just friction but the mu r friction. The r of course belongs to the r of the P. Okay, not the normal friction, the mu r friction. Okay, so then I don't I mean when it comes to an inclined plane, I prefer to mark all my forces along the plane and perpendicular. Shall we resolve the 4 mg as well? So what do we get when we resolve the 4 mg? This is the angle alpha. So this side I get 4 mg cos alpha. Are you okay? And to the other side along the plane I get 4 mg sin alpha. Are you all okay with this? So now I don't need to work with this 4 mg now. Okay, so all the forces are marked. Is my force diagram complete? Yes, right? Okay, now they are asking us to do what? They are asking us to write down an equation of motion for Q. Always when you're doing a sum, look at the number of marks and decide how much of an effort you are going to put into that question. So you can see here it's just 1 mark, which means it's minimum effort. So equation of motion for Q. What's the equation of motion we use in this particular lesson? F equals ma. So use F equals ma on particle Q, and particle is moving to the left. So use F equal ma on Q to the left. So what are the forces acting on particle Q horizontally? You only have tension. There's no friction. There's no opposing force. Equal mass is m into acceleration is unknown, right? Acceleration is unknown. So that's it actually. We just wanted to write the equation of motion. So this is it. The tension is equal to ma. Okay, so this is the answer for part A. That's why it's just 1 mark. Then let's go for the next part. For the motion of Q before Q, for the motion before Q reaches the pulley, write down the equation of motion for Q. Done. Next one, find in terms of M and G the tension in the string. And now look how many marks are there? 7 marks, which means obviously you have a lot of working to do here. You have most of the working is done here. Okay, what are we supposed to do? We are supposed to find the tension in the string. Okay, so let's do what we know. Know. So what do we know here? So what do we know here? We apply F equal ma to particle Q. So what's the next thing that's remaining for us to do? We have to next apply in these kinds of questions. We next apply F equal ma to our other particle. So what's our other particle? We apply F equal ma to particle P, and particle P is moving down along the plane. So apply it down along the plane. Apply F equal ma in the direction that your particle or your object is moving. So when we apply it down along the plane, can you all tell me what are the forces that are concerned here along the plane? Yeah, tell me, what do we have? 4 mg sin alpha is down, it's pulling down. Who else is there? Subtract, right? No one is supporting. We have the friction, mu r p, the reaction p, actually new value is given here. We can put those values now. Equals, that's all, right? Those are the only 2 horizontal forces we have. I mean, along the plane forces that we have. No, there's another one. Who is the other one? 4 mg sin alpha is acting downwards. Mu r is acting up. Who else is there? There's this tension. And that's also minus because that's also opposing the direction of movement. Do you get me? It's also opposing the direction of movement. Okay, so that's it. Those are the horizontal, along the plane forces that we have. So then this is equal to what? Mass into acceleration. F equal ma. So what's our mass? Are we just putting m here? No, our mass is 4m. So you put 4m into acceleration is a. 4ma. Are you with me? So these are there. So I have created my second equation. Now all you have to do is it's a matter of simultaneous equations. So before we move forward, shall we input the RP value and the mu value? Mu value was given to us in the sum as 1/4. What do you think about the normal reaction P? Now, even though the object is moving along the plane downwards, perpendicular to the plane, your object is in equilibrium because it's not trying to move up or down. So basically, your RP value is equal to what? Normal reaction P is equal to 4 mg cos alpha. Do you agree with me? Shall we input the mu value and the RP value? So I get here 4 mg sin alpha minus mu value is 1/4 into normal reaction P is 4 mg cos alpha minus T equals 4 ma. Okay, do you see the screen? Okay, now my task is to find the value of T. I think they asked us to find the T value. So what should I do here now? What's the next thing I need to do here? We need to combine the two equations together. Now, if you see in the first equation, do you see ma is equal to T? Can you see T is equal to ma? So what you could do is you could take the T here and replace the T with ma, or since I want to find my tension, shall I directly go to the ma value here and replace this ma directly with the T? Then I can find the tension immediately, right? So I'm going to substitute. So when I substitute, I get here 4 mg sin alpha minus 1/4 and 4 will cancel. And I get here again mg cos alpha minus tension equal, what do we get here? 4 ma is, this ma value is what? I'm going to replace the ma with T. So I get here 4 mg sin alpha minus mg cos alpha. Shall I take the minus T to the other side? Minus T goes as plus T. 4T plus T is 5T. So then I get here 4 mg sin alpha is 3/5 minus mg cos alpha is 4/5 equals 5T. So add everything together, I get here 4 into 3, 12/5 mg minus 4/5 mg equals 5T. Now subtract 12 minus 4 is 8/5 mg equals to 5T. Do you agree with me? And now make T the subject. So when you make T the subject, we get 8/25 mg. Tension equals to 8/25 mg. Do you agree with my working? Okay, let's move on to the next part. Find in terms of, okay, mg tension in the string is done. Part C, find the magnitude of the force exerted on the pulley by the string. What do they want? They want you to find the magnitude of the force exerted on the pulley by the string. So how do we do that? So they want you to find the force acting on the pulley by the string. So what you all do here is, children, in this case, you need to find the resultant force acting on the pulley. So what are the forces acting on the pulley? What are the current forces acting on the pulley? You can see there is now I have marked the forces acting on the pulley. This is a light pulley. So there is no weight of the pulley itself. All you have are the two tensions. So what I want you to do here is, I want you to resolve. Now, for example, this T is horizontal. We don't need to resolve it. Okay. So take the other T here. Take this other tension here. We can resolve it, right? Are you all with me now? Do you see what I'm trying to do here? What I'm trying to do here is, I'm trying to consider this particle like this, and I'm trying to get it all the forces in the horizontal and the vertical direction. Then I'm trying to get the sum of the horizontal forces, and I'm trying to get the sum of the vertical forces, and I'm trying to find the resultant force. Okay, look. So now at this point, you can see, let me draw the pulley up here. So this is the pulley. Let me draw it separately. This is the pulley. Okay, for the pulley up over here, I have tension, this T. The other T I have like this. Are you with me? These are the two forces acting on our pulley. However, now if I want to find the resultant force, I can't work with two forces that look like this. I have to make everything vertical and horizontal. So how do I make it vertical and horizontal? I need to definitely work on this tension, the angled one. I need to resolve this. So can you tell me what's the way I can resolve this tension? Do we know this angle? Do we know this angle? Yes. See, look at this. This is the letter, this is the alternate angle. Alpha comes up over here. Do you see? So this is angle alpha. So I'll draw it separately. It's easier when you draw it separately, right? So then I get to this side, T cos alpha. And I get down to this side, I get T sin alpha. Do you agree with my working? Okay, I get T sin alpha. Are you okay with that? So now let's take the sum of our horizontal and vertical components and take the resultant. So what do we have? Let's take horizontal x. I feel like T cos alpha, T should be bigger, right? So let's take x to the horizontal, to the right side direction. So what do we have to the right direction? We have T is positive and who is opposing that? Minus T cos alpha. So this is the sum of forces to the x direction, right? Depending on what I take as positive, I took this side. If you want, you can take the other side as positive. Then you get T cos alpha minus T, entirely up to you. So anyway, I feel like I'll take this because this looks, T cos alpha is smaller than T. Okay, so then let's get the value here. This is here, T minus T times cos alpha is how much? 4 over 5. So 4 over 5T minus 1T. Can I know the answer? 1 minus 4 over 5 is? 1 over 5. So 1 over 5T. This is basically 1 minus 4 over 5. So 1 over 5T is the x direction force. Are you with me? Get the y direction. So y direction, I only have, I think, one force. So y direction force is directly T sine alpha. Are you with me? T times sine alpha is 3 over 5. So I get 3T over 5. So now can't I find the resultant force? How do we get the resultant force acting on the pulley? X square plus y square square root. X square plus y square square root. So let's put the x value 1 over 5t square plus 3t over 5 square and square root it. Are you with me? So what do I get here? Shall I write over here? I'm writing a little bit all over the place. Okay, 1 over 25t square plus 9 over 25t square. Can you all add both of them? 1 over 25 plus 9 over 25. I get 10 over 25, right? So, and the t square. So, 10 over 25 t square. Let's simplify. We can bring the t out of the root. Do you agree with me? We can bring the t out of the root. And root 10 over 25 is? Root 10, the whole thing root, right? Root 10 over 25 gives me root 10 over 5. Is that okay? So this gives me, the simplification gives me, root 10 over 5, and I hope you can see t square can come out of the root as a single t. And didn't we find the value of our t? We found t was what? 8 mg over 25, right? So simplify. Now this is the magnitude of the resultant force acting on the pulley. So what do we get here? 8 root 10 mg, 5 times 25 is 125. So this is the magnitude of the resultant force acting on your pulley. So this is the answer to part C. Okay. Then moving on to part B, state where in your working you have used the information that the string is light. So for the string is light, again the modeling assumptions are given in your M1 book. So when the string is light, the book says, what is it? The tension is same at both ends of the string. That's what it says. Okay. So the state where have we used? We have used the fact that the tension is same at ends of the string. Okay, not throughout the string. Please do not use tension is same throughout the string. Use the tension is same. Tension is the same at the ends of the string. Or else in this case, actually we have, in this case, it's not the ends. We have like certain sections of our string, right? Do you see? Because this is the full string. So we have tension equal at this end and this end and again here and here. So then we can use the word tension is same. The book says they take a single string. So So here we have it we have the pulley also in the middle here. So we can use tension is same. Tension is same throughout. Tension is same throughout sections of the string. Question number 8. Okay, in this question, I and G are horizontal unit vectors directed due east and due north, respectively, and position vectors are given relative to fixed origin. A ship A moves with constant velocity 3I minus 10J kilometers per hour. Okay, pay attention to the units. At time t hours, the position vector of A is r kilometers. At time t equals 0, A is at the point with position vector 39 plus 5J. Find r in terms of t. So what's the main equation we use here? R equal R naught plus Vt. This is the equation we use for object moving at constant velocity with the position vector. When they give us position vectors, R is the position vector at time t. R naught is the position vector at the beginning. So R is what we need to find. R naught is given at time 0. Position vector is 13I plus 5J. Plus velocity is given as 3I minus 10J. Isn't it? And then into time. Can you all multiply? And I prefer if you could separate your I and J terms. Okay, because it's easy if you separate for the next part. I mean, it's easy when you separate for the next part. So 13 plus 3t, if I write directly, can you understand? I take 39 and 3ti and take the J1 also. Okay, so 13 plus 3ti and the next one plus 5 minus 10t times j. Okay, so I take these two together. Is this okay? Okay, then let's move on to part B. Another ship B moves with constant velocity 15I plus 14J at time T0. B is at the point with position vector 3I minus 5J. Show that at time T hours AB. Okay, before we go for the AB, what I want to do here is this. Do you realize that when I find here R equal R naught plus VT, what I basically got now, I apply this for ship A, right? I apply this for ship A. So what is the use of this equation? What does this equation give me? This equation gives me basically at any given time t, I can use the time here. And what can I get? I can get the position of the ship A. So basically, if I use time is 2 hours, I can get the x coordinate and y coordinate. I can get the position of ship A at any given time. So basically, this can also be written as what? Because it gives the position of ship A relative to where? The position is given relative to the origin. So this is basically OA. What I found as R in part A is OA. Why is it OA? Because it's the position vector of A relative to the origin. It gives the x coordinate is with I. The I gives the x coordinate of the ship and the J gives the y coordinate of the ship. So similarly, likewise, can't you find OB? OB means when you apply what? R equal R naught plus VT for what? We apply now for ship B. So R naught, the starting point, the position vector of ship B is 3I minus 5J. Do you see? Velocity of ship B is given as 15I plus 14J into T. Shall we separate this also? I want the I terms together and I want the J terms together. So what do we get here? 3 plus 15t. I prefer to keep the plus mark in the middle, definitely. This is minus 5 plus 14t times j. Actually, this should be times I. This is times j. I have separated my I terms and the j terms. Are you with me? So what does this give me? This equation gives me the position vector of the ship B relative to any given time. I can just put the t value when I know exactly where ship B is at any given time. Is that okay? Now can't we find AB? How do we find AB? AB is equal to AO plus OB vectors. If you want to go from A to B, we go from A to O and then we go from O to B like we use in triangles. Okay. So what is AO? AO is the negative of this whole thing, right? Well, if OA is this vector, AO is the negative of this whole thing. Do you agree with me? Shall I just put the negative sign inside individual? I mean, each bracket, this is negative 13 plus 3t times I I'll just put the minus mark to, outside to both the brackets, okay? Minus 5 minus 10p times j, that is AO. You have to add it to OB. OB is 3 plus 15p times I. So for OB, I didn't go to change anything because OB is exactly, I want it exactly as it is, right? Minus 5 plus 14p times j. Now add the like terms. Let's add the I terms and add the j terms. So when I add the I terms, I get here minus 13 minus 3t. Are you okay with me putting minus sign in? I'm putting the minus sign inside. Minus 13 minus 3t. Here, what do I get? I get plus 3 plus 15t. So these are all the coefficients with I. Similarly, likewise do for j also. Plus, let me put plus in the middle. What are my j coefficients? Minus 5. Be careful here. Minus 5 and what 10t? Minus into minus, it's a plus 10t. Be careful here. I open the minus, the negative sign. And here the other j term is minus 5 plus 14t. So this is my j coefficient. Add everything. Minus 13 plus 3 is minus 10. 3t plus 15 is how much? 12t. Minus 10 plus 12t I. The other guy. Minus 5 is minus 10. 10t plus 14t is how much? 24t times j. Do you agree with my answer? So basically it's, let's change and write 12t minus 10 9. 24t minus 10j. Basically, it's the same thing that I wrote. So can you see I'm getting to show that? And I have written the full working for the show that. Showing every single step of how I got AB along the way. Okay? Do you understand? Next part. Given that the two ships do not change course, find the shortest distance between the two ships. Okay, what do you mean by the shortest distance? The minimum, like the closest they travel, the one ship, both the ships are traveling along their respective path. Okay, so so they are asking you when is the distance, what's the minimum distance we have in between these two ships. Okay, so there's a reason they have asked you to find this vector AB in the previous part, because definitely this AB vector can be used for part C. Okay, now listen to this. Now you all know AB vector gives me what? The AB vector gives me this. What does this I represent here? This I, the x coordinate here represents the x distance between what and what. This 12t minus 10 gives me the x distance between the ships A and B at any given time. And here the 24t minus 10 gives me what? The y distance between, it gives me the y distance between the A and B at any given point. Okay, so we have the x distance between AB and the y distance. I mean, basically the x coordinate distance between AB and the y coordinate distance between A and B. Now, using this particular vector, can't I actually find the actual distance between AB? So you all know when we take the modulus of the vector, what do we get? When you take a modulus of a vector, you get the distance in between those 2 points. So basically what I need to do here is I'll take the modulus of my vector. So meaning for part D, for part C to find the, before finding the shortest distance, before you even think of shortest distance, find the distance. How do we find the distance? Get the modulus of your vector. When you take the modulus of any vector, it gives you the distance between the 2 points. Okay, so let's take the modulus of the vector AB. How you take the modulus of a given vector? So you square and you root, right? You square, you add the squares of the two components, the I component and the J component, you square it and you root. This gives you the distance, right? Basically, this gives you the modulus AB square, the distance square. So let's say the D square value, the distance square value is our Y, for example. Then open the bracket 12t minus 10 when you open. 12t minus 10 into 12t minus 10. Are you capable of opening the bracket immediately? You can do it immediately, please do. So these are a little bit of, I'm writing some extra steps here, but these are not necessary. You could open the brackets immediately if you are familiar with it. So 12t into 12t is 144t square. 12t into minus 10 is minus 120t. Into again minus 120 is minus 240t. Minus 10 into minus 10 is plus 100. Is that okay? And the next one, 24 into 24 is how much? Yeah, work with me. 24 into 24 is 576t square. 24 into 10 is minus 240 into minus 240 is minus 480t. 10 into 10 is 100. Is that okay? Add everything. How much is y? 144t square plus 576t square is 720t square minus 240t minus 480t is minus 240 minus 480. Add these two guys. Minus 720t. 100 plus 100 is 200. So this is the distance, which basically it gives the distance square. At any given time, when you put the t here, you get the square of the distance. Now, what do I want? Actually, do you see this this distance square equation? Do you see it's a quadratic equation and a quadratic what equation? A quadratic minimum equation, which means this graph has a minimum, and we want what point? We want that minimum point. The shortest distance is the place where you have the minimum. So what happens? How do I find the minimum? We can directly differentiate because we need to find the turning point. Yeah, you can complete the square also. Complete the squaring is also correct. Okay, but I think here completing the square is a big process. But anyway, all those methods are correct. Completing the square, and you can get the coordinate of the turning point. Or basically differentiate and set to 0. All the methods are correct. Let's differentiate and set to 0. So dy by dt, can you all tell me 720 into 2 is how much? 1440t minus 720t differentiation is 1. 200 differentiation is 0. At the minimum point, what happens? You know, definitely it's a minimum, right? We understand it's a minimum because it's a quadratic minimum graph. Definitely what we find is a minimum point here. At minimum, the dy by dt, the distance square should be equal to 0. So basically 1440t minus 720 equals 0. Can you all make t the subject? How much is t? T equals to half. Is that okay? T equals to half. Okay, now I want to find the shortest distance. What do we do now? Find this, you found the t value is half, replace the t value into this equation and get the distance square and find the distance. Shall we do it? So I replace here. So y equal, or basically it's the distance square you have here. D square equals 720 into half square minus 720 into half plus 200. Can I know how much is the d square value here? The d square answer. I want the d square answer, which means you get 20. So distance is root 20, which gives you how much? 2 root 5. This comes in kilometers because our question was everything was in kilometer per hour. Time comes in hours while distance comes in kilometers. Okay, 2 root 5. Do you understand? So this is the shortest distance. Next part D. Find the bearing of ship B from ship A when ships are closest. So just 2 marks. So when are the ships closest? We found in the earlier part the ships are closest when what? The ships are closest when t equals how much? Ships are closest when t equals half. So when t equals half, can you all get me the AB vector? We already have the AB vector equation, right? Input t as half, 12t, 12 into half minus 10i. Input the t equal half into the AB vector. Plus 24 into half minus 10 times j. How much is the AB vector? 6 minus 10 is minus 4i. 24 into half is how much? 12 minus 10 is 2j. Okay, minus 4i plus 2j. Now, what do we know about the AB vector? AB vector gives you, now from, if you are trying to travel from A to B, you have to go 4 units to the negative x-axis and 2 units up along the positive y-axis. Meaning, now where do we measure these coordinates from? Where are these coordinates measured? With respect to whom are these coordinates measured? Not from the origin. This vector is AB. AB vector means these coordinates are measured with respect to A, not with respect to the origin. So basically you measure everything from the point A. So from the point A, you go what? 4, I mean, minus 4 means you go 4 units to the left. 4 units to the left, to the west, basically. So minus 4i. You go 4 units down behind. Do you see? And then you go how many units up? 2 units up. You go 2 units up. Are you with me? You go 4 units back and you go 2 units up. And you go 2 units up. So basically this is the place where B is. Can you see? From A we go 4 units back. Back means that's why I put negative, but distance wise you go 4 units back and you go 2 units up. So end of the day, how do I get the bearing from A to B now? How do I get the bearing from A to B? Bearings are measured. We have to draw the north and we measure the angle to the clockwise direction. Are you with me? So draw the north and AB line. I mean, you have to connect the line with AB, right? So what's the bearing? The bearing angle we need to calculate is this, from the north to the clockwise direction. You see? So what is the angle we need to calculate here? All I need to calculate is this theta angle. If I can find the theta angle, all I have to do is to add it to how much? I find the theta angle and add it to 270. And I get the answer. So let's find theta. Tan theta is what I need to find. Opposite over adjacent. Opposite is 2. Adjacent, we don't put minus 4, we put 4. How much is tan inverse 2 over 4? 5650. Okay, 26.565. So how do we find the bearing? Add 270 because this small angle here is 270, this angle, and that the 270 we added to the 26.565, which gives us 296.565. And bearings are, do we leave bearings like this? No, bearings are measured from north clockwise and we leave bearings in how many digits? 3 digits. So bearing is 297. So once again, clearly understand what I did here. AB vector is, these coordinates are measured from where? Once again, when you have AB vector, the coordinates are measured with respect to A. From A, you go 4 units to the left and you go 2 units up. And then at that place, at the end of that line, you find B. So when I join these two, this is my AB vector. Do you understand? So that's the advantage of using the AB vector. If you go from the origin, it's very difficult. So that's the advantage of using this vector. Okay, so I hope all of you understood how I found the bearing and how I did this question. Okay, so this is the end of the January 2022 M1 paper.